All of the properties of exponents still apply when we're considering rational exponents. The only difference now is that our exponents might be fractions instead of integers. And so we have to remember some of our basic computation with fractions. If you're going to add or subtract, remember that you need to have a common denominator. And if you're going to multiply, you can just go straight across and multiply the numerators together and the denominators together. Then you always want to make sure that you simplify your result. So let's kind of go through our properties real quick just to review. Remember that if we are multiplying two powers, a to the m times a to the n, we're going to add the exponents, m and n. If we do a power of a power, we're going to multiply. The product property says that if I have a times b both raised to the m power, then that m power has to be applied to each factor separately. Recall that negative exponents make the reciprocal. That's how we change them back to positive powers. When we do a quotient of two powers, division, we have to subtract the exponents. And similar to the product property, the quotient property says that if I take the power of a quotient, then I end up taking the power of each the numerator and the denominator separately. So we are going to go ahead and apply each of those rules using rational exponents. Let's move this down here. Oops. Alrighty, here are some examples. We want to use the properties of exponents to simplify these. So remember, number one is that they have to have the same base. So if we look at example 1, we can see they both have a base of 7, so that means that we can do this. Now, the property says that if I'm going to multiply powers that have the same base, I'm going to add the exponents. That means I'm going to end up doing 7 to the 1/4 plus 1/2 power. I'm going to do this work kind of off to the side down here. Let's leave myself a little bit of space. So if I'm going to add these exponents, I need to add 1/4 plus 1/2. And to be able to do that, I need to have a common denominator. So I'm going to switch this one to be fourths. That makes this 1/4 plus 2/4. So you can see that we're going to get 3/4. That makes our final answer equal to 7 to the 3/4 power. Now, you might want to check if that's something that can be simplified easily, but I know right off the bat, if I look at this, that the 4th root of 7, not going to simplify out nicely, so I'm just going to leave it exactly as it is. All right, let's look at the second example. We don't have the same base inside here, so we're not going to be able to combine those. However, we do have this power that we're going to raise this product to. So we end up multiplying each of those. So we get 6 to the 1/2 times 2, which is going to be the first power. And you can either write that or not write it. And then 4 to the 1/3 squared, we'd multiply 1/3 times 2. And that gives us 4 to the 2/3 power. Since we can't simplify that any further, this would be your final answer. Number 3 is another example of multiplication. So we're going to have to add these two powers. Again, I'm going to do some kind of side work here. So I have 3/4 plus negative 1/2. So the common denominator here would be 4. That gives me 3/4 plus negative 2/4. And you can see with the negative there, that's going to end up being 1/4. So our final answer in this case is going to be x to the 1/4 power. And that's it. Now, these last few examples get a little bit more complicated. There's a lot more stuff going on. So I would say maybe go ahead and try these and see if you can make heads or tails of them. Get as far as you can, then come back to the video and kind of see where it is that you're getting stuck. I'm going to go ahead and work through those now. So if we look at example 4 here, we see that we have division. Notice that we have two different bases. We have bases of x, those match, and we have bases of y. So we can only work with the x's together and the y's together. Otherwise, they don't have the same base, so we can't do that. We're going to break this into two pieces, basically. Since this is division, we're going to subtract the exponents. So for the x side, we're going to do 2/3 minus 2. And to think of this as a fraction, I'm going to go ahead and write it over 1. And then on the y side, we're going to do 5/6 minus 1/2. All right, let's work on the left-hand side first with the x's. Again, I need a common denominator, so I'm going to multiply this by 3/3. That gives me 2/3 minus 6/3, which we can see then is going to be negative 4/3. So that's going to be the power of x that we end up with. On the other side here, our common denominator would be 6. If we multiply these both by 3/3, we get 5/6 minus 3/6, which is 2/6, and that reduces to 1/3. We want to make sure that we reduce everything as far as we can. So what that gives us is x to the negative 4/3 and y to the positive 1/3. But now don't forget, we're not done because we have a negative exponent there. Negatives are a signal that they're in the wrong spot. Right now this is all over 1. That negative would rather be in the denominator because, whoops, it makes the reciprocal. So we're going to leave the y to the 1/3 in the numerator. It's positive, it's happy. So the x to the 4/3 moves to the numerator, and this is our final answer. Okay? Number 5. And again, feel free to pause these and try them on your own before you watch me do it. That's going to help you understand what you need to practice better. So this is all different bases, but we're raising all of them to the 3/4 power. So we're going to multiply. When we multiply fractions, we go straight across, top to top, bottom to bottom. So we're going to multiply the two numerators. So for the x's, that's going to be 2 times 3. So that gives us 6 over 5 times 4, which is 20. Now, remember that when we have a whole number, that's like saying 2 over 1. So when I multiply straight across, I'm going to do 2 times 3. That gives me 6 over 1 times 4, which gives me 4. And then with the z, I'm going to multiply 1 times 3. That gives me 3 over 2 times 4, which is 8. Now, we're not finished on this one either because we want to check to see if any of those fractions can be simplified. And the x and the y, they can. So 6 over 20 reduces to 3 over 10. 6 over 4 reduces to 3 over 2. And 3/8 is going to stay exactly the same. So this would be the simplified form here. All right, the last example, number 6. You could work on this more than one way. You could start by simplifying everything that's inside the parentheses and then applying the 4th power, or you could start by applying the 4th power to everything. Now, let me explain sort of my thought process here. I always suggest, look a couple of steps ahead so you can see kind of what you're going to end up with. I noticed that I have 2's and 4's, so when I multiply by 4, those denominators are going to simplify, and it'll probably make the math a little bit easier. So I'm going to go ahead and apply the exponent first. Neither one way is more right than the other. That's just my personal preference. So each of those 4 exponents, I have to multiply by 4. So 1/2 times 4 is going to give me x squared. For the y, 2 times 4 is going to give me 8. Over, for this y down here, 1/4 times 4 is going to just give me 1. And then z to the 1/3, 1/3 times 4 is going to give me 4/3. So you'll notice that the only place that I have the same base left to simplify is here with the y's. So I'm going to subtract those. That x squared isn't going to change. 8 minus 1 gives me y to the 7th, and that'll be over z to the 4/3. And that'll be the end. So it's really just a matter of taking these really ugly problems and breaking them down into problems that are a little bit simpler, and then you can go from there. You can only simplify the ones that have matching bases, so you always want to match those up.